In this video, I want to talk about the integral coefficient of 1 over square root of a squared minus s squared, where a is a constant. Now, whenever we are having this type of integration, we are going to talk about, we are going to make use of substitution. Trig substitution. The substitution we are going to use in this process is x is equal to a sine theta. That is the substitution we are going to use. X equal to a sine theta. So the next line of action is to differentiate x with respect to theta. So we are going to differentiate this with respect to theta. That means we are going to find the x, the theta, where a is a constant. Now, let's go. The x, the theta, is equal to a cos theta. Because the differential of sin theta is cos theta, and a is a constant. When you multiply a with the differential, it gives us a cos theta. So that implies that if I make the x the subject of the relation here, the x is equal to a cos theta, the theta. So that implies that I will now replace this expression in terms of theta. I will write this expression in terms of theta. So I will now say that square root of a squared minus s squared can be written as square root of. Now from Adam, my x is equal to a sine theta. So anywhere I see x here, I will replace it with a sine theta. So I will have a squared minus my x will now be replaced with a sine theta all squared. So which is equal to square root of, then I'll have it placed there, then square of a here is a squared. Then sine theta raised to 2 is what? Sine squared theta. So the next line of action is to factor out a squared. I will factor out a squared from this. So I will have square root of, let me link it to the top like that. Then I will have square root of, that means if I bring out a square here, I will be left with just 1 minus, then sine squared theta, just like that. Now, recall from the big identity, recall that sine squared theta plus cos squared theta is equal to 1. That is an identity, it holds for any angle. Now, if I try to make sine squared theta, 1 minus sine squared theta the subject of the formula, that means cos squared theta is equal to 1 minus sine squared theta. So cos squared theta is 1 minus sine squared theta. That implies that this 1 minus sine squared theta that appeared here will be replaced as what? Cos squared theta. So this expression becomes integral of a squared cos squared theta. Then the square root of a squared cos squared theta is what? A cos theta. So that means we successfully converted this square root of a squared minus s squared in terms of theta as what? A cos theta. Now come back to the context. The context says integral of reciprocal of square root of a squared minus s squared. That means the inverse of square root of a squared minus s squared. So this can be written as square root, the integral of 1 all over. Now all of this becomes a cos theta, just like that. Then by the x, if you remember vividly, the x the theta was a cos theta. Then I made the x the subject of formula here from onset. My the x becomes a cos theta the theta. I will now replace the x with a cos theta the theta. So my the x here becomes times a cos theta and theta. So the next line of action is that a cos theta crosses out a cos theta. So what is left in the integral is the theta. Now if you are integrating with respect to theta, the integration with respect to theta is theta plus c. That c is an arbitrary constant. But we are not true yet. Why are we not true? Because in the context in our question, the question is in form of x. So we just need to convert that theta back to x. Now we now come back here. Since since x is equal to a sin theta, then make sin theta the subject of the relation. Sin theta is equal to x over a. If I do that, so that means if I want to find theta now, my theta, let's partition this portion. So from here, theta is equal to arc sine, which is also sine inverse of x over a. So I've successfully written this theta in terms of x. So therefore, my final answer, which gives integral of the theta is equal to theta plus c, can easily be written as, since my theta, now I'll transform my theta back to arc sine of x over a, so this becomes sine inverse of x over a plus arbitrary constant. So that is the end of today's class. So life is continuous, life is differentiable, life is integrable, but not the best measurable. It is a diet. Thank you.